Okay. So last class I introduced you to knowledge representation. So what is the meaning of knowledge representation? Knowledge representation means how human knowledge can be represented, but as we understood that generally for AI it is not possible for any such language to completely model the complex information that is available in the domain. Okay. Therefore such type of knowledge representation is only used as reference or for reconstruction of knowledge. Okay, and for knowledge representation we need a language, and we have chosen logic as the language. Okay, now logic has several versions. The simplest one is propositional logic. Propositional logic means I told you P, today is, what do you say, today is not raining, Q, I'll go to the class. Two statements, how they relate to each other. So that is known as propositional logic. Okay. Proposition. A proposition is a statement that by itself is true or false. All humans are mortal. It's true, right? So by definition, this is the only truth. This is the only universal truth, that all humans are mortal. But commands and questions are not propositions. Okay. So what is propositional logic? It is a mathematical system for reasoning about propositions and how they relate to one another. Every statement in propositional logic consists of propositional variables combined with propositional connectives. What are the connectives? As you will see, connectives are and, or, implication, bidirectional. Okay, so this is also known as this implication. Okay, we'll see that. So a propositional variable represents an arbitrary proposition represented by uppercase letters. For example, P. Generally, we use this as propositions. Each variable can take one or two values, true or false. Okay, so that is known as truth value. That is known as truth value. ठीक note कर दियो. Just hint दे दियो. Whatever word you write. If you don't write and only listen, you won't remember. You will forget. So try to scribble something on your note. Okay. So what are the connectives? So connectives are, one is not. So this is not P. So P is raining, not P is today is not raining. So this is read as not P. So not P is true if and only if P is false. So it is called logical negation. Okay. And P and Q. Remember the symbols, all of you, right? Not P, and P, or P. समझते लिखो symbols. The symbols you write. लिखो समझते. All of you, right? Not P, and the last one is or P, or P or Q. Last one is P or Q. So these three symbols we are going to use. Okay. Don't use the one you have used in digital electronics. Here it's a different one. It's a logical knot. Okay. Logical knot means straight line, then another line 90 degree. Okay, below, in that direction. Okay. So remember that, all of you, remember this is known as conjunction and is known as conjunction, whereas or is known as disjunction. Or is known as disjunction. Okay, conjunction, disjunction. Clear? Man rakhiyo. Negation, conjunction, disjunction. Based on this, we will further have our symbols. So next one is the implication. Implication means P then Q. P then Q. So if not Q, then not P. Is it? No. It says if P, then Q. Okay. If not P, that means not Q. I mean, in detail. So it says that it is false only when P is true and Q is false. Otherwise, it is true. Okay. This is called conditional operator. The other one is biconditional or bidirectional. So PQ, P if and only if Q. So write down. We have got negation, conjunction, disjunction, implication, and biconditional. So in logic, a truth value is represented as T, always true, and this is always false. This is always true, this is always false. So if you proceed towards doing some higher courses in AI, then you might require this. Okay. So next is, what is a well-formed formula? So what is a well-formed formula? Okay. So in that case, okay, a sentence is also called a well-formed formula, is defined as follows. So any sentence which is complete in itself is called a well-formed formula. WFF, we say that. WFF. A symbol S is a sentence. If S is a sentence, not S is a sentence. If S and T are sentences, then these all are also sentences. A sentence results from a finite number of application of above rules. A truth table, the way you know it, a truth table is similar to the way you know it. A truth table is a table showing the truth values of all these propositional connectives. Okay. So it represents the relationship between the truth values of propositions and compound propositions formed from those propositions. So operator precedence, this is very important. Operator precedence. Just like any other computation, not is first, then and, then or, then implication, then bidirectional. Okay. And all the operators are right associative. They connect to the next. Okay. It starts from left, goes to right. Parenthesis can be used to disambiguate. Disambiguate means to make it clear. Disambiguate means disambiguation means making clear. Okay, so we can use parenthesis when there is a problem. You don't understand, then you use parenthesis. Truth table, as we know, so just check it. Just check it. So P or Q is false only when both are false. Only when P and Q are false, P or Q is false. Similarly, and only when P and Q and true, then and is true, otherwise false. But implication, you see, implication means if P is true, Q should be true, and if P is false, Q should be false. Okay. If P is true, then Q should be true. If P is false, then Q should be true. Okay, those two are clear. Now about the other one. Now, if P is true, Q cannot be false because it is P implication Q. So that's why this is false. And the last one, when P is false, we need not bother about Q. Okay, it doesn't matter. Okay, we have only said that if P is true, Q is true. Q should be there. If P is there, if it is raining, it will be cold. That's it. Okay. Now it can be cold any other condition also. In detail. De Morgan's laws for logic. Not of P and Q is equal to not of P or not of Q. Not of P or Q is equal to not of P and not of Q. Tomorrow exam re, I won't ask you to solve very complicated propositions, but you might be asked to mention all this. Truth tables might be asked. De Morgan's laws. Okay. And this symbol is known as equivalence. This is known as logical equivalence. So that symbol is known as logical equivalence. Okay. Next is rules of inference. Okay. See, a rule of inference is sound if its conclusion is true whenever the premise is true. If you read well, if you come to the class regularly, you will get a job. So this is not sound because You cannot say that if the premise is true, if you come to the class regularly, you cannot guarantee that you will get a job. Cannot guarantee. We don't know. Okay, so this cannot be. So this rules of inference is not sound. Okay. Write down. First account likhai. What is the first one written? How to pronounce that? Namaste. Modus ponens. Modus tollens. Resolution and elimination and introduction. Rule likhi diyo. Write down the rules. Okay, so modus ponens says A implication B. When it will rain, A is it is raining, B it is cold. A implication B means when it will rain, it will be cold. I am just saying one situation. So in that case, if this is the premise, in that case, if it is raining, then it must be cold. So if it is given that A and A implication B, then B must be true. Similarly, modus tollens means if A implication B and not B, that means it is not A. Okay. So in this particular case, then resolution A or B and not B or C. So in that case, A or C. लिखी दियो rules गुड़ा कल लिखी दियो. The first two are very important. हमें आओ थोड़ा last slide रे we will revise this again. Okay. Now, when you study propositional logic, what you are expected to do? Your job is to convert regular English into all these symbols. Okay. So first step is we define a set of symbols. That is our choice. User defines a set of propositional symbols like P and Q. Okay. First is we define the symbols. Then we define the semantics. Semantics means what each symbol means. Okay. Symbols and what the symbols means. Semantics. P means it is hot. Q it is humid. R it is raining. Suppose, say here we are not finding the truth of the statements. We are just saying that how to convert it into the symbols. If it is humid, then it is hot. That means Q implication P. That will be written like that. If it is hot and humid, then it is raining. Hot and humid, P and Q implies it is raining. Okay. I will work hard. There are vacancies. I will get the job. So three propositions W, V, J. See, all this is I am following from that IIT Guwahati course. Okay. And one slide I will take from the IIT Madras Chennai course. Okay. So here I will work hard. There are vacancies. I will get the job. Then how to convert this? If I work hard, but there are no vacancies. If I work hard is W. There are no vacancies, not V. Okay. So W and not V implies I won't get a job. Okay. I won't get the job. Right. If I work hard and there are no vacancies, obviously I won't get the job. Right. Or if I study a discipline which has no demand in the market, then I won't get a job. Right. Okay. So next, what is a proof? What is a proof? A proof is a sequence of sentences where each sentence is either a premise or a sentence derived from earlier sentences in the proof by the rules of inference. So we use all these modus ponens, modus tollens, and finally derive a truth in logic. But as I have told you, this is generally not possible in normal human work life. Neither it is possible in AI also. So AI doesn't use it explicitly, but then it helps us in formulating knowledge. Okay. Okay. So propositional logic is a weak language. Everything cannot be represented here. And now this is the final slide I have taken from this IIT Madras course. See, actually why I told you this slide. That slide we saw different symbols. Here you will see different symbols. In the book, if you follow, there might be some other symbols, but you should know the meaning. Okay. So all of you write down all the rules. These are the same rules that we have studied. The same rules. Okay. So here instead of this implication, they are using this symbol. Okay. All of you write down the rules.